So this is the last section of new material for Chapter 2, and it's on number bases. And this might not be something you've ever seen before. It's not particularly hard, but it's probably going to be new. So the number system that we're working in is base 10, and I can tell that we're in base 10 because we use 10 distinct digits to represent any number possible. We have the numbers 0 and then 1 through 9, so there's 10 distinct digits, and in base 10 you expect to see 10 distinct digits. If I had a reason to use a different base, I'd have to have less or more digits depending on what the base is. If I had to work in base 4, then I should only have 4 digits that I'm allowed to use to create every single number, and those probably would be the numbers 0, 1, 2, and 3. Four distinct numbers. From those numbers, I'm going to create every number. Base 2, which is actually a common base to work with, is called the binary number system. And of course, if we're working in base 2, we're only allowed to have 2 digits, and those would be the numbers 0 and 1. This is a base that I even have some familiarity with. Back in the late 70s and early 80s, when I was in high school, we had the latest and greatest computer from Radio Shack at Thunderbird High School that had 4K of memory, 4,000 bits, I guess that means that we were allowed to use in it. We used to save our programs that we wrote on a cassette tape that you could play back on your car cassette player back in the day, and it make little beeps. But anyways, back in the day, computers worked in base 2. The code, the assembly language that worked for computers was working in base 2. This is because essentially back in the day, computers could only sense whether there was an electrical pulse or not. I think if there was no electrical pulse, it was a 0. If there was an electrical pulse, there was a 1. So the language that they used to build the DOS system that used to run computers before Windows worked in base 2. And everything needed to be written with just 1s and 0s. We'll learn a little bit about base 2 in the future. Now, I'm pretty sure that computers, they work a heck of a lot faster now, and apparently working in base 10 wouldn't be something that would allow computers to get the same speed that they have now. Computers now usually work in base 16. Base 16, as opposed to being called binary, is called the hexadecimal system. And to work in base 16, computers need 16 distinct numbers to work with. And some of the numbers, because we kind of already have, we're not going to create new numbers. So some of the numbers are given symbols. In base 16, we have the 10 digits that we use in base 10. And then we have a number to stand for 11, which is A. B stands for 12. C stands for 13. D stands for 14. E stands for 15. And there shouldn't be an F there, because I guess there is. And F stands for 16. We'll say, I don't know that I actually did say that wrong. Ha ha ha. A stands for 10, B stands for 11, C for 12, D for 13, E for 14, and F for 15. You go up to one number lower than the base. So if you took some sort of machine or assembly language class now that's dealing with computers, my guess is you'd work it in base 16, and base 16 is not particularly fun to work with. I don't envision a lot of you working ever in base 16, and so we'll just focus on the easier bases, base 2 through base 10. I found some other things on the internet that I thought was interesting, just about different number bases, so I'll just kind of read through this. Historically, most but not all cultures have used base 10. The Yuki Indians of California used base 8 because they count the spaces between their fingers rather than the fingers themselves. The Babylonians used base 60, and the Mayans used a mix of base 20 and base 18. I'm sure I copied this from Wikipedia. I'm assuming that it's true. You can kind of read through this. I thought this was interesting. Abraham Lincoln's Gettysburg Address begins with 407 years ago. This means 87, and apparently that's base 20. So other bases are used, but realistically, we live in the world of base 10. Here's a little bit more on base 16. When I made up my web page, I had to pick the color of the fonts, and the computer program that I was using to make my web page, when you go to pick a color for a font, you define it by a letter name or a number / letter name in base 16. Apparently, on the program that I use, if I wanted to get white, I would type in all zeros. It would give me a white. If I want to get, the code for black is all zeros. The code for white, I don't remember this, is all Fs. And it just doesn't print so well, but that color that this was, if you opened up my website, which is a purple color, that's the code for it. It's a base 16 number. So we're going to need to, in this section, be able to write numbers that are given in base 10 in other bases, and we need to take numbers in other bases and convert them to base 10. And it's going to be really important when we're working with numbers in bases to know powers of that base. So the first example I'm going to do is I'm going to take a number that's written in base 5. So I can tell that this number right here, 1403 base 5, is in base 5 because the 5 is subscripted. I have no sense for what that equals to, how big or small that number is, because in other bases it's not obvious. This is not 1403. It's probably less than 1403, but it could be bigger than 1403. So I'm going to convert this number that's in base 5 to base 10. Super easy to take a number in base 5 and write it in base 10. The first thing I'm going to do is I'm going to write the numbers backwards. So I'm going to write the 3 first, the 0 second. This is trying to accomplish my goal of writing the number 1403 base 10 into, base 5 into base 10. So I wrote the number backwards. Then I looked at the base 5 and I took each one of these numbers, 3, 0, 4, and 1, which is a number written backwards, and I multiplied each by a power of 5. So the 3 I multiplied by a power of 5, the 0 I multiplied by a power of 5, the 4 I multiplied by a power of 5, the 1 I multiplied by a power of 5, and the power of 5 that I multiply by, I start the first 5 with a power of 0, and then each subsequent 5 I add 1, so I went from 0 to 1 to 2 to 3. And then these individual products I need to add together. So to convert 1403 base 5 into base 10, first I write the number backwards. So instead of 1403, I write 3041. Then I multiply each one of those numbers, 3, 0, 4, and 1, by a power of 5, starting with the power of 0, ending with the last power, in this case 3. And I put plus signs between the numbers, and now I'm just going to figure out each. The first computation, I need to do exponents first, and anything to the 0 power is 1. So 3 times 5 to the 0 is equal to 3 times 1. I bring down the plus sign, and then I figure out what 5 to the first power is. 5 to the first power is 5. And then I do 5 squared and 5 cubed, all of which I have memorized, but you can use your calculator for. After I do the exponents, I do the multiplications. So the first multiplication I did was 3 times 1, and I got 3. The second multiplication I did was 0 times 5, and I got 0. Then I did 4 times 25 and got 100. And lastly, I did 1 times 125 and got 125. I added up these numbers. Apparently, they add up to 228. And this tells me that 1403 base 5 is equal to 228 base 10. Normally, when we write a number, we don't subscript the base, but there's an assumed subscripted base 10 when we're working in base 10. Just like there's a lot of numbers that we assume in algebra, the base 10 is an assumed number. Let me do one more of these and then we'll do some examples. This is a horrible example because there's so many numbers, but in base 2 it happens that we get a lot of numbers. So I want to change 101110 base 2 into base 10. Well, how do I do it? I write the number backwards. So writing the number backwards, I write, this 0 first, that 1 last. I just take these numbers and write them backwards. So I wrote 011101. So this 011101 is the number written backwards. So to convert from a base that's not base 10 into base 10, the first thing you do is you take your number and you write it backwards. And then next to each one of those numbers, you multiply by the base with an exponent. So I get 1 0, 3 1s, another 0, and a 1. And then, so I took the number, I wrote it backwards, multiplied each one of these numbers by the base, and then I attached exponents starting at 0 and incrementing up 1 each time. And then I put plus signs between. So this computation, which is much nicer, written more nicely down here, is exactly what I do. I wrote the number backwards, 011101, multiplied each of those numbers by a power of 2, gave each of the powers of 2 an exponent starting at 0 and working my way up till I was out of 2's, and then I put a plus sign between. If I was doing this, I would use my calculator to do the entire computations, and it would be simple to do on my calculator. I could just go 0 times 2 up arrow 0 plus 1 times 2 up arrow 1 plus 1 times 2 up arrow 2 plus 1 times 2 up arrow 3 exponent 3 plus 0 times 2 exponent 4 plus 1 times 2 exponent 5. When I hit enter, it's going to do the entire computation for me, and it's going to tell me that 101110 base 2 is equal to 46 base 10. So the first 20 problems, we're given numbers in alternate bases and we're asked to change them into base 10, and this should be friendly. It's the going backwards, given a number in base 10 and converting to another number, that's a little bit hard. So let's work on one together just in case I haven't done enough. So to do number 1, we're asked to convert 213 base 4 into base 10. How do I do that? I take the number and write it backwards. So I wrote 312. Next to each of the numbers, I'm going to put a times 4 because the base that we're starting with is 4. Now I'm going to give each of the 4's an exponent, starting with 0 and then going up by 1. And then I'm going to put plus signs between the terms. I have no desire to do this by hand, but you're more than welcome to do it by hand. By hand, what I would do would say this is 3 times 1 because 4 to the 0 power is 1, and 3 times 1 is 3. This is 1 times 4 because 4 to the first power is 4, and then 1 times 4 is 4. And then this is 2 times 16 because 4 squared is 16. And then 2 times 16 is 32. If I added these together, 3 plus 4 is 7 plus 32 is 39. This might be the only one I do by hand because I strongly prefer just doing it on my calculator because my calculator is not going to mess up like I'm going to mess up if I try to do them by hand. So by hand, 3 times 4 to the 0 plus 1 times 4 to the 1 plus 2 times, oops, we have to enter it right though, plus 2 times 4 squared, and I get 39. The answer to problem 1 is 213 base 4 is equal to 39 base 10. So let's do, you can do 3, I'll do 4 this time. For my number 4, I'm going to write the numbers backwards. I'm going to write a 1 then a 3. I'm going to multiply by 4 to the 0 and 4 to the 1, put a plus sign between, and then use my calculator. 1 times 4 to the 0 plus 3 times 4 to the 1. My answer for problem 4, 31 base 4 is equal to 13 base 10. Your problem 3, your answer should be 19 base 10. I'll do 5 with you. So I'm going to write the numbers backwards. I'm going to write 1, 1, 1, 0, 1. That's writing the number backwards. And I'm going to multiply each by a power of 2. I'm going to start with 0, sneak that plus sign in, bump the exponent on the 2 up to 1, put a plus sign in, bump the exponent up to 2, put a plus sign in, bump the exponent up to 3, put a plus sign in, bump the exponent up to 4, break out my calculator. 1 times 2 to the 0 plus 1 times 2 to the 1 plus 1 times 2 squared plus 0 times 2 cubed plus 1 times 2 to the 4th. And I get for problem 5, my answer is 23. I did more work than I have to do, because like this piece right here, I really didn't need to enter that. 0 times anything is 0. Had I not entered that, I still would have gotten 23 for an answer. And some of these exponents I could have done in my head, but sometimes when I do work in my head, I make mistakes. So the answer to 5 is 23. There's your problem 7. I'll do problem 8, so you can work on problem 7 and maybe not watch me do problem 8. You're going for 466 base 10. In case you need it, I'll do problem 8. For problem 8, I'm going to write a 4, a 3, a 2, and a 1. That's writing the numbers backwards. And then I multiply by 6 to the 0. Put my plus sign in. Multiply by 6 to the 1. Put my plus sign in. Multiply by 6 squared. Put my plus sign in. Multiplied by 6 cubed. And then calculator time. 4 times 6 to the 0 plus 3 times 6 to the 1 plus 2 times 6 squared plus 1 times 6 cubed. And for this problem, I get 310. So the base 10. So 1, 2, 3, 4 base 6 is equal to 310. Base 10. And again, your problem 7, you're shooting for 466. Maybe we'll just do 2 more of these, and then we'll go to the backwards way. I just feel like that's enough already. I'll do your number 9. You can pause the video and try to get the answer, so you don't have to watch me do this. For number 9, we're going for 108 base 10. For number 9, I'm going to write 3, 1, and 4. Write the number backwards. Then times 5 to the 0 plus 1 times 5 to the 1 plus 4 times 5 squared. No desire to do that by hand. I can definitely be more clever about pressing buttons on my calculator than I'm being. I could do some of the exponent work in my head, but I don't really need to. So I get 413 base 5 is equal to 108 base 10, and that matches up perfectly. Technically, we have 1, 2, 3, I don't know, 4, 5 problems to do. This feels like overkill. Maybe we'll do 2 more, and then we'll skip a few problems. And you can do 11. I'll do 12. When you do 11, you're shooting for 189. When I do 12, I'm going to write 5, 1, 2, 3, which is writing the number backwards, and then times 7 to the 0 plus times 7 to the 1 plus times 7 squared plus times 7 cubed. This is going to be a large number. So 5 times 7 to the 0 plus 1 times 7 to the 1 plus 2 times 7 squared plus 3 times 7 cubed. My answer, 3215 base 7 equals to 1139 base 10. Again, your answer for number 11 is 189 base 10. And then last problem, and then we'll go backwards, which is much, much harder. And I'll work through number 13 with you. So I'm going to write the number backwards. I'm going to write 1, 0, 1, 1, 1, and then times 2 to the 0 plus times 2 to the 1 plus times 2 squared plus times 2 cubed plus times 2 to the 4th. And if I don't mess up, I'm going to get 29 base 10 for my answer. So So 1 times 2 to the 0, 1 times 2 to the 0. I'm not going to do the 0, I don't need it. Plus 1 times 2 squared, plus 1 times 2 cubed, plus 1 times 2 to the 4th, and I get that 29. So any piece that has a 0 is going to equal to 0, so you don't have to do that on your calculator. If you feel the urge and you want to do everything, here's problem 15. The answer to problem 15 is 146 base 10. Here's problem 17. The answer to problem 17 is 29 base 10. And there's problem 19. The answer to problem 19 is 139 base 10. Apparently, I don't know where problem 21 is because I must have deleted it. Oh, no. Oh, 21 actually has a base in it. Look at the answer to 21. It already has a base in it. So it's the answer to 21. I'm converting something in base 10 to base 5. It's 133 base 5. This is a little bit tricky. So I'll jump into it now, but this is the easy half. The next half is a little bit tricky, but it's not particularly hard. So to go backwards is the hard way. To go from base 10 to another base can be a little bit tricky. There's 2 ways to teach this. You might have already learned this in high school. If you know how to do this, if you know how to convert from base 10 into another base and you remember the strategy and you like the strategy, you don't need to watch the video. You can just do the problems. There's 2 ways I know to convert from base 10 to a base other than 10. One is using division, and the other is using subtraction. And for me, doing subtraction is easier than doing division in terms of my students do better. So my first example that I'm going to do is I'm going to convert 1,742, that's a base 10 number, into a base 5 number. The first thing I need to do is I need to know every power of 5 that's less than 1,742. I have a sheet that I made up for myself, and I'm going to look at the powers of 5 on this sheet. So I see 5 to the 0 is 1. I'm trying to find every power of 5 that's less than 1,742, and I'm going to go on my table that I made up just to save myself some time. Those are all powers of 5. They're all less than 1742, but there's a power of 5. The next power of 5 is bigger than 1742. So in order to change from 1742 to base 10, base 5, I need to know all the powers of 5 from biggest to smallest that are less than 1742. So 625 is a power of 5. It's the biggest power of 5 that's less than 1742 because the next power of 5 is bigger than 1742. So 625, 125, 25, 5, and 1 are all the powers of 5 that are less than 1742. Super easy to figure out what 1742 base 10 is in terms of base 5. How do I do that? I'm going to start off using the largest power of 5 that's less than 1742, and I'm going to start subtracting. So I'm going to take the 1742, and I'll pull out my calculator, and I'm going to subtract 625. I'm going to subtract until I get to a number less than 1742 minus 625. I get 1117. That's bigger than 625, so I'm going to subtract 625 again. So I'm going to go minus 625 a second time. That's 492. That's less than 625, so I'm done with this step. This step is going to give me the first number in my answer to what 1742 is base 10 and base 5. The first number I'm going to write in my answer is 2 because I was able to subtract the largest power of 5 that's less than 625 2 times. I'm going to carry this 492, which in some sense is the remainder, And what I'm going to do is the same thing with the next number in my list. The next number in my list is 125. In this 492, I'm going to start subtracting 125 until I get a number smaller than 125. So I'm going to go 492 minus 125. When I do that, I get 367. That's bigger than 125, so I need to subtract 125 again. 367 minus 125 is 242. That's bigger than 125, so I need to subtract 125 again. When I do that subtraction, I get 117. That's less than 125, so I'm done with this step. And as I go to write my answer, now I know the second number in my answer. The second number in my answer is going to be 3, because I was able to subtract 125 3 times. I'm going to carry this remainder over, and I'm going to move on to the next number in my list, and the next number in my list is a 25. I'm going to start subtracting 117 minus 25, and I'm going to do it until I get a number less than 25. So I'm going to go 117 less 25. That gives me 92. That's bigger than 25, so I'm going to subtract 25 again. Minus 25 a second time is going to give me 67. Bigger than 25, so I subtract again. Minus 25 a third time gives me to 42. That's bigger than 25, so I'm going to subtract again. And then minus 25 a fourth time, I get 17. That's less than 25, so I'm done subtracting 25. I'm ready for the next number in my answer. I subtracted 25 1, 2, 3, 4 times. The next number in my answer is going to be a 4. Done with the 25. Moving on, taking my remainder, carrying it over. The next number I'm going to subtract is 5. I can do this without my calculator for the first time. I'm going to go 17 minus 5. I get 12. That's bigger than 5, so I still subtract. I'm going to do 12 minus 5 and get 7. That's bigger than 5, so I still subtract. And then 7 minus 5 is 2. That's less than 5, so I'm done subtracting. I write a number for my answer, and the number that I write in my answer is a 3 for the 3 times I was able to subtract the 5. And then I'm going to work on the last power here. The last power is 1. I bring my remainder over. And now I'm going to start subtracting this power of 5. I'm going to go 2 minus 1 is 1. 1 minus 1 is 0. I'm done subtracting because I've gotten to 0. I've used up all the powers of 5 that are less than the number 1742. My final number, my answer is going to be 2. And now this is a base 5 number. So 1742 base 10 is equal to 23432 base 5. In my videos, I do a really structured, or in my homework, I do a real structured table, but I don't think that's really necessary. So let me just jump right into the homework so the video doesn't get too long. And I'm going to work with you through number 21. So to do problem 21, this is base 5. I need to look at base 5 and find all the powers of 5 that are less than 21. So I'm going to look at 5 to the 0. I know that that's equal to 1. That's less than 43, so I'm going to write the next power of 5 down. 5 to the first power is equal to 5. Less than 43, I'm going to write the next power of 5 down. 5 squared is 25. That's less than 43. I'm going to write the next power of 5 down. 5 cubed equals 125. That's too big. So the numbers that I'm going to work on to get my 43 written in base 5 are 2, 5, 25, 5, and 1. So what I'm going to do is I'm going to subtract from 43 25, and then 5, and then 1 to help me get my answer. So I'm starting with 43. And what do? I take the biggest power of 5 that's less than 43, which is 25, and subtract it. So I'm going to go 43 minus 25. and that gives me 18. Because that's less than 25, I'm done with that step. I'm going to be done with this 25. Part of my answer is going to have a 1 in it because I was only able to subtract this one time. I'm going to carry my remainder of 18 over, and now I'm going to start subtracting 5, which is the next power of 5. That's smaller than 25. I'm going to go 18 minus 5 is 13. 13 minus 5 is 8. Still bigger than 5, so I can still subtract. 8 minus 5 is 3. I'm less than 5, so I'm done subtracting. The next number in my answer is going to be a 3. The first answer number is a 1. The second number is a 3. I bring my remainder of 3 over, and now I'm going to start subtracting 1. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. Once I've used up all the numbers and gotten down to 0, I'm going to be done. And the last number for my answer is going to be a 3 because I was able to subtract the 1 3 times. And I converted to base 5, so I'm going to subscript the 5. If I look at the answer that I had for problem 21, I get 133 base 5. Maybe I'll work through, well, I'll do 24, and then I'll wind up doing 25 with you, because that's a little bit tricky. So to do problems 24 and or 23, because we're going to base 3, I need to know the powers of 3. I can do these on my calculator if I don't know them. 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. Yuck. 3 cubed is 27. 3 to the 4th is 81. 3 to the 5th is 243. I could just go 3 up arrow 5. And 3 to the 6th is 729. So I'm not going to worry about it. I need to subtract every power of 3, unfortunately, that's less than 315. So I'm doing this. Your problem is going to start similarly, except you're not going to have a 243. So I'm going to subtract the number 243, and then 81, and then 27, and then 9, 3, and 1. And let me just get going. I'm going to start off with 315. I'm going to subtract until I get a number less than 243. So first subtraction, 315 minus 243. I get 72, which is less than 243. Part of my answer to this problem is going to have the number 1. In fact, that's going to be the first number in my answer. I'm going to bring this 72 over, and I'd like to subtract 81. But I can't because 72 minus 81 would give me a negative. So I'm going to say I can't subtract that because I'm not allowed to go negative, and 72 minus the 81 that I'm asked to subtract would cause a negative. In my second position, I put a 1 in my first position because I was able to subtract 1s. I'm going to put a 0 in my second position because I wasn't able to subtract, and I'm going to take that remainder of 72 and take it over to the next column and start subtracting 27. So I'm going to go 72 minus 27 and get 45. And then 45 minus 27 and get 18. I was able to subtract twice. I can't subtract again because I'm less than 18. The next number I'm going to write in my answer is a 2 for the 2 times I was able to subtract. I'm going to carry my 18 over, and now I'm going to start subtracting 9. So 18 minus 9 is 9. I'm going to subtract 9 again. 9 minus 9 is 0. So I'm able to subtract 18 2 times. So I'm going to put a 2 in my answer, and here's the tricky part. I'm going to take my remainder of 0. I'd like to subtract 3, but subtracting 3 would give me a negative number. So I'm not allowed to subtract 3 because I'm not allowed to get negatives. And where I put these little crosses, I put a 0 in my answer because I wasn't able to subtract that number. I'm going to take that remainder of 0 and bring it over to the next column where I'd like to subtract 1, but I'm not able to subtract 1 because 0 minus 1 would give me a negative. So I put a cross through it and put a 0 in this position. So I get 1, 0, 2, 2, 0, 0, base 3 for my answer. When you did problem 23, you're supposed to get 2, 1, 2, 2, 0, base 3. I'm not sure how easy that was. Let's just do 25 together. Look at all the zeros in there. That's a good example. So 25 is living in the world of base 2. Base 2 is the worst base. The smaller the base, the worse they are to do. So what I'm going to do, 2 to the 0 power is 1. 2 to the 1 power is 2. I don't need my calculator for these, but you can use your calculator. If you didn't know that 2 squared was 4, you could just go 2 squared and it tells you it's 4. If you don't know that 2 cubed is 8, you can bust it out on your calculator. So if you don't have the powers memorized, you need to get every power of 2 in this problem until you get bigger than 73. So all the powers of 2 I need are here. 2 to the 6th is the last power of 2 that's less than 73. 2 to the 7th is bigger than 73, so I'm not going to worry about it. Now I'm going to try to leave myself some room. I'm going to write all these numbers, all these powers of 2 backwards. So I'm going to write 64, and then 32, 16, 8, 4, 2, and 1. And what do I do now? I start subtracting. First, I'm going to take the 73 that I'm given, and I'm going to subtract 64. So 73 minus 64 is 9. 9 is less than 64. I can't subtract it again. Part of my answer, the first number of my answer is going to be the number 1 for the one time I was able to subtract 64. I'm going to carry my 9 over. I'd like to subtract 32, but 9 minus 32 gives me a negative. I'm going to put a cross there because I'm not allowed to subtract 32. I'm not allowed to go negative. The next number in my answer is going to be a 0 because I wasn't allowed to subtract 32. I'm going to carry this remainder of 9 over to the next column where I'd like to subtract 16. But 9 minus 16 gives me a negative. I'm not allowed to get negatives. I'm going to cross this out and put another 0 in my answer because I wasn't able to subtract 16. Finally, I'm going to carry this 9 over to the 8, and now I can start subtracting again. 9 minus 8 is 1. I'm less than 8, so I'm done subtracting. I was able to subtract 8 one time, so I'm going to put a 1 in my answer for the 8 position. I'm going to carry my remainder of 1 over. I'd like to subtract 4, but 1 minus 4 is negative, so I put a cross there, put a 0 in my answer because I wasn't able to subtract the 4. Carry this remainder of 1 over. Try to subtract 2. 1 minus 2 gives me a negative. I put a cross, a 0 in my answer, carry the 1 over to the last column. I'm able to subtract it. I get down to a 0, so I'm done. I've used up all the powers of 2. I'm down to a 0. The last number I'm going to put is a 1, and then I need to put a base 2 in my answer. So the answer to problem 25 is supposed to be 1001001 base 2. I'll work through 27 with you just because maybe you need to see more examples. It would be nice if you did 27 and then watched me do it, or fast forward and don't watch me do it, but you're going 1, 2 zeros, 1, 0, 1, base 2. So for 37, the powers of 2 that I need, for 27, the powers of 2 that I need 2 to the 0, which is 1. I need 2 to the 1, which is 2. I need 2 squared, which is 4. I need 2 cubed, which is 8. I need 2 to the 4th, which is 16. I need 2 to the 5th, which is 32. I don't need 2 to the 6th, which is 64, because it's bigger than 37. So I'm going to take these powers and write them backwards. 32, 16, 8, 4, 2, and 1. So I'm going to go 32, 16, 8, 4, 2, and 1. And I'm just going to start subtracting. First subtraction, I'm going to go 37 minus 32. I can do that in my head. That's a 5. That's less than 32. I'm done subtracting 32. In my answer, I'm going to get the number 1. I'm going to carry the 5 over to the next column. I want to subtract 16, but 5 minus 16 gives me a negative. I'm going to cross that out. I'm going to put a 0 in my answer because I'm not allowed to go negative. Now I'm going to carry this 5 over to the next column, where I'd be asked to subtract 8. Well, 5 minus 8, unfortunately, is still negative. I have to cross that out, put a 0 down, bring my 5 over to the next column where I'm going to start subtracting 4. I can finally subtract again. 5 minus 4 is 1. I'm less than 4, so I'm done subtracting. The number I get in my answer for this one is going to be 1. I'm going to carry the 1 over. I'd like to start subtracting 2. 1 minus 2 is negative, so I can't subtract it. I put a 0 in my answer. I carry the remainder over to the last column where I start subtracting 1. And 1 minus 1 is 0. I'm at 0. I've used up all the powers I need to do. The last number I get in my answer is a 1. And I need to have a base 2. So my answer to problem 27 is going to be 100101 base 2. Just in case this is hard, why don't you pause the video and try to do problem 29? And in problem 29, we're going for 10321 base 4. I'll do problem 29 just in case you need to see it. So for problem 29, I need to know that 4 to the 0 power is 1, 4 squared is 16, 4 cubed is 64, 4 to the 4th is 256. I don't really have 4 to the 5th memorized, but I don't need it here because 4 to the 5th is too big. It's 1024. So all the powers I need to write down are 256, 64, 16, and 1. These are the numbers I'm going to need to subtract. Start by subtracting from 313. So 313 minus 256 is 57. That's less than 256, so I'm done with this step. Part of my answer is going to have the number 1 for the one time I could subtract. I bring my remainder over. I'd like to subtract 64, but 57 minus 64 is negative. I put a cross through it, put a 0 in my answer, carry the 57 over, and start subtracting 16. I'm afraid I'm going to make a mistake if I do this without my calculator. So 57 minus 16 is 41. 41 minus 16 is 25. And 25 minus 16 is 9. Oops, I forgot a number here. I forgot 4 to the 0. I forgot 4 to the 1 power. I forgot 4 to the 1 power is 4. And I'll sneak it in right there. I missed the power. Answer is still correct. The next number in my answer is going to be 3 for the 3 times I could subtract 16. The problem here was when I was going to get to this place, I was going to start subtracting 1, and I can't have numbers bigger than 3 in base 4. So I just noticed I forgot that power. So I snuck that power back in, and now I'm going to start subtracting 4. I'm going to go 9 minus 4 is 5. 5 minus 4 is 1. Can't subtract again without going negative. I'm going to put a 2 in my answer. I'm going to carry the remainder over and subtract 1. 1 minus 1 is 0. In my answer, I'm going to get a 1. And my base is going to be 4. So it's 1, 0, 3, 2, 1, base 4. Let me just check this to make sure I have it right. So 10321 base 4. How about we just maybe do 2 more problems? I'm feeling this is getting to be long enough. I'm going to do my 32, and you can do 31. When you do 31, which looks a lot easier, 31 you're going for 121 base 6. For my problem, unfortunately, this base 8 is horrible. 8 to the 0 is 1. I really don't feel like doing this. 8 squared is 64. In fact, I'm not going to do it. I don't feel like work. Base 8, you could have to subtract 7 times. I just don't feel like doing it. Let me do 31 because it's so much nicer. And again, you can definitely not watch me do this. I kind of prefer that. But if you need to watch me do it, watch. So there's the powers of 6 that I need. The next power would be bigger. So I'm going to write these numbers down. 36, 6, and 1. First thing I'm going to do is go 49 minus 36. 49 minus 36 is 13. I can't subtract again without going negative. I get a 1 in my answer for the one time I could subtract. Carry over the 13 and start subtracting 6. 13 minus 6 is 7. 7 minus 6 is 1. Done subtracting 6 because I'm less than 6. The next number in my answer is 2. And then start subtracting 1. 1 minus 1 is 0. I'm at 0. I've used up all the powers. Last number in my answer is a 1, but I need to sneak that base in there. So for 31, it's 121 base 6. All right, maybe, how about, even though there's a handful more problems, why don't you just do 33 and 35, and we'll skip 37, and I'll do 35. And you can do 33, and 35 will be the last number that I do. So for 35, 4 to the 0 is 1. 4 to the 1 is 4. 4 squared is 16. 4 cubed is 64. And 4 to the 4th is too big. It's 256. So I'm going to write the numbers backwards. 64, 16, 4, and 1. And now I'm going to start subtracting. For problem 35, I'm going to go 143 minus 64. I get 79. Now I'm going to go 79 minus 64. And I get 15. Done subtracting because I'm less than 64. First number in my answer is going to be a 2 for the 2 times I could subtract 64. Now I'm going to carry my remainder over, and I want to subtract 16. 15 minus 16 would give me a negative. I'm not allowed to subtract it. I cross it out, put a 0 down for my answer, carry the 15 over to the next column, which is subtracting 4. 15 minus 4 is 11. 11 minus 4 is 7. 7 minus 4 is 3, and now I'm less than 4, so I'm done subtracting. I was able to subtract 3 times. The next number in my answer is going to be a 3. I carry the remainder over and start subtracting 1. 3 minus 1 is 2. 2 minus 1 is 1. 1 minus 1 is 0. I've used up all the powers. I'm down to 0. I'm done. The last number I get in my answer is a 3, other than sneaking the subscripted base 4. So for 35, I was supposed to get 2033 base 4. When you did 33, hopefully you got 32033 base 5. And if you have the strongest desire, you're welcome to do problem 37. 37 is a monstrous. There's way too many things to subtract. But if you try 37 because you just feel like it, you get 2 1s, 2 0, 3 1s, 2 zeros base 2. I'll call that the end of the video. Hopefully you feel good about switching both directions, from base 10 into another base and from another base into base 10.